finish up on the pre-chapter 10, Skills and Practice. We're looking at a page of discovering the area of formulas using geometric and algebraic properties. I was going to paste this into a smartboard document and use it there and bring in a ruler and some things like that, and I decided that wouldn't. I would just spin it around here, rotate it here in Adobe, and go from there. So anyway, area formula is a square. Now, let's start with a rectangle first of all. When we think about area, we're thinking about length times width. And when we're thinking about length times width, then we have a width of 2 and a length of 4. And if we think about a 2 by 4 and how many blocks there are, there's 1, 2, 3, 4, 5, 6, 7, 8 blocks. And to get the number of blocks, you could say 2 times 4, which is length, and our length times width. And so to get the area, we multiply the dimensions, you see. Okay? And then everything else is really based on that. So let's follow the rectangle through, and then we'll go to the square. This rectangle was 2 centimeters wide and 4 centimeters long. So it's 2 centimeters by 4 centimeters. When you multiply the numbers. 2 fours are 8, and you multiply the names, and you get a new name. And when you multiply with like bases, you add the exponents. And so we would get 8 square centimeters. See the visual of a square centimeter? There's 1, 2, 3, 4, 5, 6, 7, 8 of those square units. Okay? So the area is 8 square centimeters. There's two ways we can write the formula for area. Then we could say area is equal to length times width. Area is equal to length times width. You multiply the dimensions. Or we might say that area is equal to base times height. Now, we're going to use base times height. If I abbreviate it here, I would have L times W, length times width. Or if I abbreviate it here, I would have B times H, or base times height. We're going to use base times height because in a triangle we use base times height. In a trapezoid we use bases, and so then we can see the similarity between one area formula and the other. So if we think about the rectangle being base times height, and the fact that a square is a rectangle, then the area of a square would also be base times height. But in a square, the sides are equal. So your base and height are equal. So if we call the base a side and the height a side, then for the area of a square, we would get the length of a side square, or S squared. Okay? This particular picture had a square whose dimensions were 2 centimeters by 2 centimeters. So you would take 2 squared, which is 4 centimeters times centimeters is centimeters square, and so we would have 4 square centimeters. Okay? So we begin with the area of a rectangle, which is length times width, or base times height. And we say, well, a square is a rectangle, so the area of it is base times height. But since the base and the height are the same, then we can use the formula side square. Now watch as we come on down here. You look at a parallelogram. On a rectangle, we used one side as the base and another side as the height. The reason we can do that is because in a rectangle, the angles are 90. Height is how tall something is, and how tall something is in geometry we call an altitude, and an altitude is a perpendicular segment. Well, if we look at this parallelogram, its base is 6 centimeters, just like the top. But how tall that parallelogram is not this other side because it's leaning. How tall something is, or the height of something, is from the top of it perpendicular to the bottom of it. So the 2 centimeters is actually the height of the parallelogram. Well, you may say, well, how could we come up with the formula? Well, if we took this little triangle that's right here and we moved it over here, we would actually have a rectangle whose base length is the base of the parallelogram and whose height is the height of the parallelogram. So if the formula for area of a rectangle is base times height, then the formula for the area of a parallelogram must be base times height only, because from a parallelogram you can create a rectangle whose base is the base of the parallelogram and whose height is the height of the parallelogram. Well, what about a triangle? The base is 12. The height is how tall it is from the top straight down to the bottom. So the base is 12, and the height is 6. But you think, well, we got to go back to a rectangle. What is a triangle in relationship to a rectangle? Well, if you took another triangle congruent to that one and set it on top of it, you would have a parallelogram. So a triangle is half of a parallelogram. If the parallelogram formula is base times height, then the triangle would be half of that, 1/2 base times height. So the formula for area of a triangle is 1/2 base times height. Now, on the rhombus, we have 4 little triangles that are all congruent to one another because of the properties of a rhombus. We also know that the diagonals are perpendicular and bisect each other. So this little piece is equal to this little piece. This little piece is equal to this little piece. So if I look at that one triangle, it's 1/2 the base AE times the height BC. Triangle ADC, or ABC, I'm sorry, this whole big triangle ABC, excuse me, is 1/2 the base AC times the height. Let me just start over. I'm making a mess out of this. Okay, start over. The area of triangle ABC, that whole big triangle, is 1/2 its base AC times its height BE. The area of triangle ADC, the one on the bottom, is also 1/2 its base, which is the same as the other one, AC, times its height, which is ED. So if I wanted the area of the rhombus, I could add those together. So I could say 1/2 AC times BE plus 1/2 AC times ED. If I factor out the common factor 1/2 AC, I would get 1/2 AC times BE plus ED by segment addition. BE plus ED is BD, and I still have that AC. Now let's look at what we've got. We've got AC, that's this diagonal. BD, that's this diagonal. What we've got right here is 1/2 diagonal 1 times diagonal 2. So the formula for area of a trapezoid is 1/2 diagonal 1 diagonal 2. So what you see here is we started out with the area of a rectangle, base times height. We said a square is a rectangle, so it's base times height, but the sides are the same. So your base is S, your height is S, so it's S squared. A parallelogram, if you take the triangle off one side, stick it on the other, you get a rectangle. So it's also base times height. A triangle is half a rectangle or half a parallelogram, so it's half base times height. When we took half the rhombus at a time and came up with an equation and did a little bit of factoring, we ended up with the area of a rhombus being 1/2 diagonal 1 times diagonal 2. If we look at a trapezoid, this little triangle here, that piece could go to the top, and this little piece down here could go to the top. And when you did, you would have a rectangle. The height of the rectangle is the height of the trapezoid, but the base of this new rectangle is shorter than the original base, the original lower base, but it's longer than the original upper base. It's somewhere between those two, and so it is the average of the bases. So the base of the new rectangle we just created is half the sum of the bases. That would be the base of the rectangle times the height of the rectangle, and so we get 1/2 height times sum of bases. If I scoot the height over to here. Half the sum of the bases is the median. So if we replaced half sum of bases with median, then we could say that the area is median times height. Okay? And I'm going to let you study regular polygons, circles, arc lengths, and sectors on your own. There's some discovery work. On the sectors and arc lengths, we're saying a fraction of, and you can see that in your student edition, and then we're going to look at those things again when we teach the lesson. But I wanted to kind of get you started on understanding the progression of these formulas, especially from a rectangle through a parallelogram, through a triangle, through a rhombus, through a trapezoid. Okay?